All right, so now we're doing our last video for this section, which is an application of our surface area, because of course we have to. They're the fun part of all of this. Once you've learned how to find the surface area, you then get to apply it. So a group of engineers are building a parabolic satellite dish whose shape will be formed by rotating the curve y equals ax squared about the x-axis. The dish is to have a diameter of 10 feet and a maximum depth of 2 feet. Find the value of A and surface area of the dish. So if the diameter is 10 feet, that means we're going to go from -5 to 5 because you have to split it. 5 to the left, 5 to the left, 5 to the right. Maximum depth of 2, you would think it's the center, which is it is. So we have a depth of 2. So if that's a depth of 2, that means all the way across, that would then be 5, 2, and -5, 2. So here's what's happening. So we have this parabola with A in it. And so remember, as A gets bigger, our graph becomes more narrow. And that's our standard one with an A of 1. And then as our A gets smaller, our graph gets wider. And what we're trying to do is get it to touch right there. So 0.08, you can see we're getting that point that we want. It's right there. It doesn't want to give it to me. I don't know why. Let's try this side instead. Yeah, but we're right there. Right at it. So 0.08 is our A, but we can't just use Desmos every time and go, oh, I'm going to move this thing up and down until I find it. It could take a long time until you get there. So what we're going to do is mathematically. All you have to do now is take a point. You think this is our y equals ax squared, right? And so if that's a point on it, that's our x comma y. So if we plug them in, we would end up with a y of 2, a 5 squared. So if we divide both sides by 25, this gives us an A equals 2 over 25, which is 0.08. So now we know that our y is equal to 0.08 x squared. So now we have our A value. So that was the first one. Find the value of A, and we're done. Now that we have our equation to have that dimension, right, this is now the next part. We're going to rotate it to find the surface area. So if you click on that link, it will bring up our Desmos graph, which is this. And so as you rotate it, and obviously this is not the bottom of the satellite dish. We're talking about just this part of the surface because we're looking at just the curve itself. So just this curve, and then as we rotate it, that's the surface that we're getting. So as you rotate it, there's our surface. Let's go a little bit slower. So you can see it's forming as we rotate that curve all the way around, and in this case we're rotating it around the y-axis. And we get our satellite dish. So this top part is our satellite dish, not the bottom, but it looks cool having it. So since we're rotating it about the y-axis, we're going to use s equals 2 pi x ds. And since we have y equals, we're going to use this one, the dy dx. So these are the equations we're using, and we will be able to find our surface area. So let's start with our ds. So in order to do that, we're going to find dy dx, and that would be 0.16x. And then the next thing to do is square it. So we're going to square it, and we get 0.0256 x squared. So our dy dx squared. And then what's next on our step? Add 1. So we'll just put it here, plus 1. And then the last step is to square root it. So our ds would equal the square root of 0.0256 x squared plus 1, or you could be using the fraction form of it, which is 16 over 625 x squared plus 1. Either way, it's the same with the dx. All right, now we just have to plug them in. So our surface area would be the integral of 2 pi x ds, and then now we got to go to our graph to see what we use. So again, this is a 2 pi x dx, right, that we're using, so we need to look at our x values. Our x is going to go from 0 to 5. So s equals 0 to 5, 2 pi x square root. I'm going to use the fraction one. Actually, let's use the decimal. See, what's going to happen here is we are doing an application. So we don't have to find the exact value right now. I just want the approximate value, because that's what we're going to be using. And by the way, this is dx. If we had been doing dy, so if we had an equation with x equals, we would be going from 0 to 2. But we're going from 0 to 5, and that would encompass this entire rotation. Okay, so now we just have to plug that in our calculator and see what it gives us. Clear out what we had. So math 9, we're going from 0 to 5, and we've got to put the 2 pi in. Second 2 pi x second square root. If you were going to use this by hand, this is a nice clean u substitution. So you would say u equals the inside, and you would get just the x, which would cancel that one. So everything would work out fine. So if you really want to find the exact answer, you can. It's a lot harder with a mouse than you would think. All right, so we end up with 90. 90.01. So we'll do that. 90.01. 90.01, and then it's feet. So we might as well just make it 90 feet. And does that sound right, though? So this is surface area. So when you're doing an area, what would be the units? All right, I know you guys are shouting it out. Good. So it's 90 square feet. So that would be the surface area of that satellite dish. So if they have a 10-foot wide with a depth of 2 with a parabolic shape rotated, you'd have 90 square feet. So what's happening here is they're just taking a generic form and they're making you form the equation, which is what would happen in the real world. You would know that it's a parabola that you want to form. You would have your dimensions, and so you could easily find out what the parabolic shape is based on y equals ax squared, because we're centered at 0, 0.